Good evening, everyone. In this video, I'll be talking about system design decisions. Okay, so I'll be discussing about estimating the performance and making a reusable plan. Okay, for the application which you are developing. So early in the planning of a new system, one should actually prepare a rough estimate about the performance. Okay, so how the system, how much will be the performance of the system, how it should be executing, where it will be executing, what sort of hardware it is actually required. So all these things basically come into this sort of estimation of system performance. Okay, primarily the idea is to determine if the system is actually feasible or not. Okay, it don't have to be very accurate. Okay, accuracy is not so important, but you need to have an approximate estimate. Okay, so the calculation should be very fast and can involve general common sense. Okay. So we may have to make some simplifying assumptions. We may have to approximate sometimes, estimate certain things, and we can even guess if it is necessary. Okay. So that's the basic idea of estimating the system performance. So let us look at the example of ATMs, which we have been talking about, okay, as part of these videos. Suppose we are assume like we are building or we are planning an application for ATM network for a bank. Okay, so then basically think about this one. The bank will have approximately, say for example, 40 or 50 branches. Assuming like if each branch will have one ATM terminal, that means like you will have 40 terminals. Okay, if there are 40 branches, then you will have 40 terminals. On a busy day, say for example, half the terminals are busy at once. Okay, so that means like at any time, like 20 branches, 20 ATM terminals are always busy. Okay, at any particular time, or even to the extreme, like think like all the 40 of them are busy during a day. So you can actually have an estimate. Okay, so when you are designing that application, okay, so you can actually think about these things, whether all the 40 will be busy always or like only 20 of them will be busy at any time. And then like you need to think about, like say for example, each customer will take approximately a minute to perform a session, because like he has to insert the card, put all the pin details and everything, and he has to do one transaction. Okay, most of the transactions will involve a single withdrawal or deposit. Okay, withdrawals are a lot more common, okay, at the ATM machines. But the idea is like you can actually have an estimate of the session timing. Okay, so in this case, like we can assume like it is for a minute. Okay, so if we really think like all the ATM terminals are busy at any time, okay, and then like and each user for his session takes like approximately a minute, that means like a peak requirement will be about 40 transactions a minute for this particular system. Okay, so that means like an approximately a transaction per second. Okay, so 40 transactions per minute. Okay, so you can approximately assume like 60 transactions per minute. That means like approximately a second for a transaction. Okay, but if you think about like one transaction per second, you really do not need a very fast computer hardware for that particular ATM for its design. So that is the performance estimation which you are doing in the stage of system design. Okay, but think about the same situation. Okay, say for example, if it is not for the ATM example, however, if you are building an online stock broker system, then the situation will be completely different. There you may have to have several transactions per second, and then like the transactions need to be supported within milliseconds. Then the complete design decisions will change. Okay, so that's about the system design. That's about the performance. But similarly, you can have the same estimates for the data storage as well. Okay, so for the same ATM case, and then like for the bank example, count the number of customers. Okay, and then like you basically estimate the amount of data for each customer, okay, that is required, and basically just multiply them. That will actually give you an estimate like how much of data storage is actually required. Okay, in this ATM application, and then like say for example for doing the banking transactions, the requirement for data storage is a little bit more severe than the ATM computing power. Okay, So that means like data storage need to be given more priority. Okay, so more severe. Okay, so the requirement is more strict there. Okay. However, like the data storage, even for this particular application, for this ATM application, it is not enormous. It is not pretty huge. Okay, there will be several transactions, so you can still store them in reasonable storage in some form of database or whatever it is. But think about the same case, say for example, like you are trying to build an application which is based on satellites. Okay, so and then like it assume like it basically takes images from the area, and then like the data is actually coming back, and then like you are doing some processing. Say for example, you take the satellite images, and then like you basically try to see like which of the low-lying areas in a city or in a particular region, and then like you can actually estimate like if there are floods or something, like which of them will be severely affected, and then like based on that one you can have a plan. So if you are trying to build an application something like this requires actually huge data storage. And of course like you need to get all these satellite based images, so that means like access bandwidth should also be pretty huge. Okay, so it always depends on the application. Okay, but then like during this system design stage you need to have an approximate estimate of the performance of the system to basically see like whether the application is actually feasible or not. Okay, that's one of the design decisions. Then let us look at making a reusable plan. Okay, so reuse is often cited as one of the major advantages of object oriented technology. However, reuse does not happen automatically. Okay, you need to basically have all the plans ready. Okay, so there are two aspects of reuse. One is about using the existing things. So for example, somebody has already built an existing thing and you are actually reusing in your system. Okay, so that's also an aspect of reuse. Alternatively, you will be creating reusable new things, okay, which others can use in their own projects. Most often like we will reuse existing things, and only a small fraction of times or like a small fraction of developers actually create new things. Okay, building reusable things, okay, reusable new things actually takes a great deal of experience. Okay, so let's look at these things. Okay, so reuse plan is actually critical. Okay, as I already mentioned, like this basically takes care of two aspects. One is using the existing things, and then like creating reusable new things. So in terms of reusable things are concerned, okay, reusable things actually include models, libraries, frameworks, and patterns. Reuse of models is often the most practical form of reuse. Okay, so whatever the model which you are developing, okay, the logic which you are using in a particular model may be applicable to multiple problems. Okay, and if a company is developing multiple applications, okay, say for example, it may reuse some of these models in the next applications which it will be building. Okay, that's about reusing the models. Then comes the libraries. Okay, a library is a collection of classes that are actually useful in many contexts. Okay, so we have been using several libraries. Okay, so especially in the labs, like you have been using these Java different libraries, network libraries, util libraries, etc. Okay, so generally a library is a collection of classes. Okay, the classes must have thorough descriptions. Okay, which will actually help the users to determine their relevance. Okay, so they need to have detailed descriptions. Okay, until and unless you maintain detailed descriptions, okay, users will not know like how to use those classes. Okay, then more or less like that library is not often used. Okay, not often reused. There are several good qualities for a class libraries. Okay, uh, these are the qualities which actually state like okay, certain library is actually very good. Okay, one of them is coherence. The library should be organized about a few and well-focused themes. Okay, so if an library is doing about certain thing, it should be doing only that particular aspect, and then like that should be good for it. Say for example, if you are trying to develop a networks library, okay, so it should take care of all the things which are related to networks. Okay, so don't add too many things into the library so that like it really becomes big at the same time like it loses focus. Okay, it should be focused at a particular thing. And a good library is always complete. Okay, so it provides a complete behavior for chosen things. Whatever it really would like to do, let it do it complete. Okay, then it should be consistent as well. Okay, so for example, like whatever the polymorphic operations, okay, which are defined within that library should have consistent names and signatures across all the classes. Okay, so basically like don't mix them, and then like say for example in one of the class like uh, give a different name for a polymorphic operation, and then like in a different class you give a, of course, a synonym or a different name, okay, for a for an operation, okay, for a polymorphic operation, then it is not a good design. Okay, so it should be consistent. Efficiency is also very critical. Okay, good libraries also provide alternative implementation of algorithms. So something like say for example, if it is a library for sorting algorithms, okay, so you need to have different algorithms considering like different space requirements and time constraints, etc. Okay, time complexity, etc. So it should be efficient in that sense. Okay, so that means like it should provide alternative implementations for different algorithms. The library should also be extensible. That means like users should be able to define their own subclasses, okay, for the library classes. Don't restrict the users from not being able to extend the libraries. Okay. So a good library is also extensible. And then like it should be also need to have this sort of genericity. A library should use parameterized class definitions where appropriate. So we looked at templates and those things. So that means like a library, if today like you can actually use that library for one set of objects as inputs, okay, in future like it should be also be extendable, and it should be generic enough, like should be able to use it with a different class or its subclass or something like that. Okay, say for example, if there is a utility class is there, okay, a linked list or something like that one. Okay, so if you can answer one type of object, okay, so that would be a simple design. Okay, but then like if you can add any type of object into that one, okay, into those things, so then it is generic enough. So a good library basically has these sort of qualities. But then like whenever you are trying to reuse libraries from different sources, okay, problems can actually arise when you are actually integrating class libraries from multiple sources. Okay, these things basically happen because like most often developers use some sort of pragmatic decisions across classes. These policies may be sensible individually. Okay, so in that particular context, like it may look sensible, but fundamentally they are incompatible with other classes libraries. Okay, so then when you are using class libraries from multiple sources, then different problems arise. Let's look at some of the examples where like are like situations where like such things basically will pop up, such problems will pop up. So one of them is this argument validation. Applications actually may validate arguments by collection or individually as entered. Okay, so think about a situation. Say, for example, like if you are looking in terms of command interfaces, you will put all your arguments, and then like all your arguments will be validated at once. So that is collective validation. So collective validation is appropriate for command line interfaces. Whereas, like if you are developing a responsive user interfaces, okay, something like an online application or something like that, where you will have a form and you will be entering each and every value into that form, and each of these values will be independently verified, or like say for example a group of these values, group of these arguments, okay, will be validated at once. Okay, so your application may take any of these things, but then like say for example if you take libraries, in one of the libraries like uses one of these approaches where it basically validates all the things collectively, another one basically uses individually. Then if you are trying to develop a user interface based on these libraries, two different libraries, the final solution, okay, will be really awkward. So it will have very bad user interfaces. Okay, so these are the things like which you should be considering. At the same time, like error handling. Okay, Say for example, in methods in one of the library may return the error codes to the calling routine. Say for example, in Java, like we have seen the exceptions. Okay, in exceptions, like okay, so basically like in the design choices, okay, say for example, like the exceptions are the errors, you can actually route to the method which actually have called. One of the library may take that instead of handling that error within it. Okay, so it may throw that one to the calling routine. Alternatively, another library may actually directly deal with these errors. Again, like if you are trying to integrate these two libraries, issues may pop up. Okay. Similarly, in terms of control paradigms, applications may adopt event-driven or procedural control. So we will discuss these, what is event-driven and then like procedural control in detail later. But then like event-driven means like say for example a certain event has occurred and then like you will do something. Whereas procedural driven is like you will call a method and then like based on that one you will get a response. Okay, there can be different control paradigms. So and these libraries may basically be following different control paradigms. At the same time, like say for example, some of the libraries may have group operations. Group operations are often inefficient. Say for example, like you have an object delete primitive. This may actually require, like say for example, in terms of a database, you want to delete an object from it. Then it may basically have to log the database, then make the deletion, and then like commit the transaction. And this is like for a single object deletion. Now the point is like if you want to have a group of objects to be deleted in a single transaction, if you really want that one, then the library must basically provide you that group delete function. Okay, then it is not so great. Okay, so these are the things like which you should be considering while during the system design. Again, garbage collection is also an issue. Class libraries may use different strategies to make these memory allocations and memory leaks. Okay, handling this garbage collection, etc. Okay, so it also depends if you use multiple libraries. Okay, so then you should also be considering these things. And name collisions is also another very big problem there. So class names, public attributes, and methods should not collide actually. Okay. Say for example, like assume like you are getting different libraries. Okay. So and then like they have exactly the same name. Of course, one approach to handle that one, which we have seen, or the design decisions, is like basically maintaining different packages. Okay. But at the same time, like some of the class libraries actually add distinguished prefixes to the names to avoid these sort of collisions. That's about libraries and then like how you can actually reuse them. What are the features of a good library and then like what are the issues, different issues that may pop up. Then the next one is this frameworks. Frameworks can also be reused. Actually, a framework is a skeletal structure of a program that must be elaborated to build a complete application. You already have a default skeleton. Okay, some basic skeleton is already there. Okay, and you basically take it and you actually extend it, you elaborate it to build a complete application. Most often they may consist of specialized abstract classes with the behavior that is specific for that particular application. Okay. In addition to these classes, they may also include a paradigm for flow of control and shared invariants. Okay, so the variables like which will be used across the application it may also have. Okay, so that's about reusable frameworks. But framework class libraries are typically application specific. So they are specific to an application and then they are not generally suitable for generic uses. Okay, that is something which we should remember. So then there comes these patterns. Okay, a pattern is a proven solution to a generic problem. Okay, so that means like it is already tried and tested for a particular problem and then like there was an ideal solution which was developed, which was recorded as a pattern. Okay, which was documented as a pattern. Okay. There can be patterns for analysis. Okay, how to do analysis for different applications, and there can be patterns for architectures, for design also, like there are patterns, and also for implementation as well. Okay, a pattern is more likely to be correct and robust. Okay, because it was already tried, tested. Okay, so several people have actually tested it. So it is much better than using an untested and then a custom solution. So it's always good to use reuse patterns if they are existing. So patterns are prototypical model fragments that actually distinguish some of the knowledge of the experts. For example, like say for example, if you think in terms of Java programming, then there are these Java design patterns. There are a lot of patterns existing. Okay, so you can actually check through them. Okay, if anybody is really curious about. Okay, so you can actually have different patterns for how you can actually create objects. So using singleton pattern, or like say for example, like yeah, different patterns exist actually. Okay, so then somebody might think like, what is the difference between a pattern and a framework? Because framework also like provides a default structure for an application. Pattern actually provides some way of dealing how you can actually develop that application. Okay, actually a pattern is typically a small number of classes and relationships. Okay, it is not so used. If you look in terms of Java patterns, like you will have like two or three classes, or like say for example interfaces, etc. Okay, it is never like a huge library or something like that. A framework in that sense is much broader in scope and covers an entire subsystem of an application. So that's the difference between a pattern and an application and a framework. So regarding the reference is concerned, okay, so basically like well, again, this is an excerpt from chapter 14. We are still in chapter 14 of this object-oriented modeling and design with UML. Okay, Michael Blahanji and Sumba. For the people who are curious about Java patterns, like I am leaving a reference. Thank you very much for your attention.